So rectangular components, which we just discussed now, are convenient for finding the sum or resultant are of two forces which are concurrent. What do we mean concurrent? Remember? So we got F1 and we've got F2. They're concurrent. Okay, so one way of finding the resultant of these is, we know, just use the parallelogram and find that resultant R. But another way is to first, instead of using the parallelogram law, we break each one up into its x and y components, x and y, and then we add up the x's and we add up the y's. So here R is equal to F1 plus F2, vector form. What does F1 look like? It is the scalar F1x times I plus F1y times j. So this is F1. And then we've got F2. You've got these are written now in terms of i's and j's. All you need to do is add up the i's, put them together, F1x plus F2x, because these are pointing in the same direction, and then we add up the j's, right? We add up the y component, F1y plus F2, and so this is then Rx, that is the x component of R times I plus the y component of R times j. And just in terms of scalar values, that is Rx right there. This is just the scalar value of in the x direction, and that's Ry, which is what we're seeing here. So sum of the forces in the x is equal to that, sum of the forces in the y is equal to that. What does it look like if we draw the vectors? Well, okay, so these are different vectors to the ones that I just drew. But so now you got F1 there, and actually F2, whoops, F2 is actually down there, so that force is being applied there, okay, because it's a concurrent force. So just remember that, right? The force is being applied here. That's where it's being applied. F1 and F2 are being applied at that point. It's a concurrent force, but they're showing us how to break each one up into its x and y. So here we've got F1. If you break it up into its x component, there's F1x, and you break that one up into its vertical component, there's F1y, right? There's F1y, F1x, and then this one is so there's F2, so you've got F2x would be that there, and then F2y would be that there, okay? So now we add up all the x components. There's F1x, and then we add up F2x, and we get Rx. Okay? Get Rx right there. We add up F1y, but now you can see that F2y is negative because it's pointing in the negative direction. So it's F1 minus F2 gives us Ry. Does that make sense? If that was pointing in that direction, then we would add that on top. So now we've got Rx plus Ry. Rx and Ry gives us R, the final vector sum.